So this is the Dubai 210 kit sent by gearbest.com, and I chose this kit because it's actually a really good set of quality components. To have everything that will work together in one bag is pretty cool, especially for those who aren't very comfortable ordering a bunch of separate parts. Now, the kit I got had one major downside, and that was the ESCs. They weren't quite up to the same standard as the rest of the hardware, and they had a lot of problems. But I had them fix it, and now the link in my description is to the same kit but with much better ESCs. Painless360 has a much more extensive video series using this kit, and he had problems with his ESCs too, but he was able to fix them by updating the firmware. If you want to watch his videos, I'll link them below too. This video is going to be a little bit echoey and fairly long, and I'm hoping to help demystify this quadcopter building stuff and to inspire you to try it out yourself. Some of you may find this therapeutic and might just learn a few tips and tricks and see how I like to build a racing quadcopter. It comes with two sets of props, one red set, one black set. These are 50-45 bullnose props. They look pretty generic. I would definitely recommend just grabbing a whole bunch of some more. Let me go. Only like $2. These are my favorite right now. They're 3-bladed Dow crystal props. All right, now the first thing to do, of course, is to put it all together because you're freaking excited. All right, now this is a little unfortunate. I wish that it came with the nylon standoffs, but you're gonna need some of these. These are black or white or whatever. Just a little kit of nylon standoff material, and you're going to use that to stand off the power. That'll just hold those things there. Let me know what this looks like. Anyways, now another first thing you need to do is make sure that this flight controller works. Now this is a clone, it's kind of cheap, and it might not work, so it's just a lot easier to know if you need to talk to somebody now than go through all the work of building this thing and then to find out that it doesn't. So you can download the Chrome app called Clean Flight Configurator and use that to make sure this works. So what we're going to do is we're going to use a micro USB cable. What we want to see is some lights. Oh goody, some lights. Hit connect. Alright, it's connected, and look at that, it's already working. Now you can mount this sideways 90 degrees so that the USB is sticking out the side, and then we'll just change that in configuration. Basically say, hey, rotate the front 90 degrees and then everything. Then this will be the front. But for now, it's like this. So, cool. Now we also want to make sure that this can load new firmware. Firmware flasher. This is an SP Racing F3 board. So you just go down here and you find the latest, the SP Racing F3 right there. So that's the closest to the top. So that's once you've selected the firmware you want, you go and say load the firmware from the internet. So now there's some release notes that says what's different about this new firmware. You can read it, it's kind of interesting, but you don't need to. And then just hit flash firmware. So it's flashing. Sometimes it'll say failed, and then it'll be like, oh, that's weird, and then you try it again and it will work. But for me, this seems to be working the first time. So that's nice. Okay, programming successful. Cool, so let's go to connect. It'll probably be acting kind of slow and funny and like, what's going on? So what you should do is just lay it down kind of flat. It doesn't have to be perfect, but just nice and really still, and hit calibrate accelerometer. There, and now it's nice and reactive. I'm confident that this flight controller is a good, healthy, not a dud. Okay, cool. Now let's start building this thing. Let's grab some standoffs. Battery pins are facing backwards. Yes. And while you're building one of these, I definitely recommend, if you don't have a lot of flying experience, to get one of these. These are awesome. They're like between 10 and 15 bucks on Amazon, and they're like, I don't know, I really love these things. But they'll teach you the basics. It'll just get your brain to think about forwards, backwards, left, right, drift, correction for drift, and yaw, and maintaining orientation. All those things that require really, it's just a fundamental set of like the way your brain works that you need to train by just flying these every afternoon, every freaking time this thing charges, which takes like 5 minutes. Just go through a battery. In fact, the charge is way too fast actually. And then that way when you fly this thing, it will seem a lot more natural, and you're a lot less likely to break it. Don't make excited you make dumb decisions. That's the best advice I can give. Being excited can really help you to get things done and be productive, but it can also make you make dumb decisions. So now obviously there's a lot of wire here, and I don't want wire here. So if you want to mount your speed controllers, like, I don't know, under the power distribution board or something, you could do that, and it might look really clean, but I prefer to just put them on the arms. I think it's just fine. and it also allows for the cooling of the prop wash to cool the ACs. So that's what I recommend, but you can do whatever you want. So here's what I like to do to solder the speed controllers to the motors. So I'm using the iron and maybe a little bit of solder just at first, just to get the heat conducting, to heat the wire itself up to the temperature to melt the solder. So I'm actually melting the solder onto the wire, not onto the iron and then to the wire. This way the solder is fresh and fresh flux to help it flow into the wire, and that is a nice good joint. So I'll just melt those together. Then I'll move to the middle one, and some tweezers are really helpful for things like this. Let's put the middle one right there. Now, we don't know yet if this is going to spin the right direction, so we could either program it to spin the other direction, or we could swap any two wires later. Yep, that looks good to me. All right, let's do 3 more. These come with longer and shorter screws. We're going to choose the shorter ones. If you use the longer ones, you'll probably break your motors. Maybe just add a little bit of solder to get the heat to conduct really quickly from the iron's metal to the traces here. But you don't want to just keep adding solder until the base metal is hot enough to actually melt the solder by itself. Otherwise, you're going to get a cold joint. So the reason this is going a lot faster now is because all these traces are actually connected together, right? It's just distributing the like polarities. Once once I heat this up, it'll actually heat up all the other positives. Just like it conducts electricity, it also conducts heat. So all these traces are already pretty hot. And that's why it's so hard to heat them up at first, is because you're actually heating all of them up. Tinned those. 4, 3, 2, 1. It's about right. Stay still. Transition. And we're good. Uh, 4, 3, 2, 1. Check every single one of these. Black, negative. Red, positive. Black, negative. Red, positive. Positive, negative. Positive, red. Black, negative. Okay, because I've done that wrong before. The last thing we need for this power distribution system here is the battery plug. Now you can buy one of these online, or you can make your own. I actually stole this off of a bad speed controller, but unfortunately the kit does not come with one of these, so you'll have to get one or make one yourself. Cool, just a quick test fit. And let's pull off this flight controller and solder our pins on it. Now, if you were to do this super clean and professionally, and you were really serious about this, you can just do exactly what we did here, but with this. you can actually cut off this wire and solder that directly to the output pins here. And I love doing that, but for this build I'm going to use pins because it's just way easier. It's just way more user-friendly to have pins. So we're going to put the pins on. So this flight controller came with, I have a set of straight pins. So this would just go like, you could just put that right there, and then that's vertical, or you can use the angle pins, and then you can either have them sticking out, but then that's taking up a lot of space. Wait, I just flipped it around and went this way. Now that's nice and compact, but the thing is we need to make sure that these plugs can fit. So what we're going to do is plug a couple of these plugs in and just say, all right, so it's got to be like that. So it's got to be angled up just a little bit, and so we'll just test fit it with the pins. So like that. So we'll just plug some of those in, and then we'll solder these pins on here. So what we're going to do is we're going to heat up the little circle and get the solder to just kind of flow onto it and form a nice little bubble. All right, that's it. See that little crown that's just filled in and it's wicked itself, wetted itself, and spread out? That means it got hot enough. Now let's see the other side. Did it go through? Yeah. You'd see right here that it actually wicked its way up the little pin here. That's really good. Now I don't know if I'll get that for every single one, but that's good. So that's a tack there, and then I'll go over here and we'll get this one. Now remember, we're not going to just hot glue some solder on there. We're heating up the pins, and then the pins take the solder. We're melting the solder onto the pins or onto the pads. Yeah, that's working great. So I've got a couple tacked, so that means this should stay in place. And now I can plug, into any of these. And that's fitting just fine. So now it looks like this. I'm going to finish soldering every one of these. There it goes, and release. It's a little bit much actually. See how it balled up there? I want it to be like a Hershey's Kiss, not like a soccer ball. All right, 1, 2, 3. Better. What we do with this is number 1, and that means that the signal wire from this speed controller controlling this motor goes into pin 1 on the flight controller. So on the flight controller, on the bottom side, you can see 1 through 8. There's 8 outputs, meaning this could actually control an octocopter. With most circuit boards, negative or the ground is closest to the outside of the board. So, you can also see right here. So negative, positive signal. So the inner one is the signal, and so which pin is the signal? It's the bottom one. So we want to put the white wire, which is the signal wire, at the bottom, and the black one at the top. This would be opposite if we were to have these switched around and have the pins facing outward. Motor 2, 3, motor 4. In order to power the flight controller, it needs 5 volts. Now we can give that via the USB cable, so we can plug it in and use it with the USB cable, but we can't do that in flight really. So what we do is we give 5 volts to the rail here. So remember, the outside's negative, the inside's positive. So any one of these plugs, we could just plug in a power cable and give it power. And we'll take the power from the power distribution board. We want to make sure that we use this 5 volt output. So we're going to just test that all the motors are doing what they're supposed to be doing. So it's pretty much guaranteed that probably 2 of these are going to be spinning the wrong way, and we're going to have to reverse, either mechanically switch 2 wires to make it spin the other direction, or if you wanted, we could program it to spin the other way. For today, I'm going to just switch any 2 wires because that's the most simple, and that way you don't have to learn a new method. The flight controller. So let's plug it in and see what happens. Could be smoke. When you make contact, don't go bleh, because if there's smoke or something, you could probably recover it if you pop it out just in time. So let's see. Whew. All right, that seems good. It's always a little bit terrifying the first time you plug in the battery. What we're going to do is we're going to set standard. We're going to set the max throttle to 2000 and the minimum command is what the motors tab here. So let's just set that 1000. Okay, save and reboot before leaving. Now, what's going to happen is I'll go into motors and I'll just unplug the motors so they don't do anything. But the flight controller is going to send the signal between, right now it's sending at 1000, right? So right now it's giving at 1000. 1000 means 0 throttle. 1000 is below any speed that the motors are going to spin at. So, and then at the top, now it's going to 2000. But before it was going to 1850 because that's what it was set at, because that's just default. So now what we're going to do is we're going to calibrate the speed controllers to operate between 2000 and 1000. So I'm going to bring all the motors up to 2000 and then I'm going to plug it in. And it starts to sing a song and then you bring them to 0. But now we're just going to leave it at 0. So start at the top, plug it in, that sets the max throttle, bring it to the 0, sets the minimum throttle, and it's calibrated between 1000 and 2000. But now what we're going to do is we're going to tell the flight controller what the speed controllers are actually doing. So what we're going to do is we're going to take the master switch and we're just going to click on it and then we're going to go up with the up arrow so that we can bring the numbers up manually by hand. And we're just going to bring it up until the motors start to spin. Ooh, yeah, that was all quite at once. So see right here at 1025, only one motor's going, not the rest. These should all start at approximately the same time, but it's okay if they're a little off. So now, oh wow, just 1026 and they're all going smoothly. One below that, 1025, and now they're freaking out, 1024. So we know that 1024 is nothing, 1025 is in between, and 1026 is when they're all spinning about smooth. Okay. Now, what we're going to do is, basically we're going to tell the flight controller at what number all these things are still spinning smoothly. So in air mode and stuff, when you bring the throttle to 0, you want the minimum throttle that these motors are still able to work at comfortably. So this is a little bit too slow because what if we have an air load on the motors and they have to restart? Right? If they have to restart, you lose control in the air. So we're going to give it a little bit of safety room. So let's see, let's go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's about alright. Usually you find the minimum throttle, then you add about 10 to it. So we can see that the number is 1036. Go into configuration, go to minimum throttle, and type in 1036. Alright, save and reboot. But now what we're going to do, see, by default that number is actually pretty high, and with high power motors with big props, you can actually find that 0 throttle on air mode is going to have you climbing. And you're like, how the heck do I get down? Or just way too much throttle. So this way you're going to have like a perfect controlled rock, falling rock kind of a feel, and it's absolutely awesome. So we've set the minimum throttle, and now we're going to tell the flight controller what the speed controllers do at maximum throttle. So it's not really good to run your motors at full throttle for extended periods of time without any load on them. And so what we're going to do is we're going to be using this 3-cell, so it's not going to spin as fast as on a 4-cell. And we're only going to choose one motor. So I'm just going to choose this one or whatever. So I'll go ahead and go into the motors tab, and then I'll hit that, okay. And I'll just choose motor 3. And I'm going to go all the way up to the top, and then I'm going to start bringing the number down until I hear when the motor's actually changing speeds. So there's probably going to be a dead band at the top where changing numbers don't equate to changing speed. And so the reason this is important is when you punch the throttle, you want to be using your full throttle, but you don't want to be stuck in a zone where changes don't actually do anything. Otherwise the flight controller won't be able to control it very well. So here we go. And then I'll bring the numbers down. Oh, already? Where was that number? 1980. So I'm going to go into configuration, and then I'm going to choose the maximum throttle as 1980. There, maximum throttle set to 1980. Okay. And save and reboot. Alright, so now we have the motors tuned, the minimum and max throttle tuned and set. So now that I know that all that works, I'm going to go back and I'm going to solder on my FPV components. Now, if you're not going to use FPV at first, that's okay. We'll just skip this step. But So this is a plug for my video transmitter, and that comes with the video transmitter, and here is a camera plug, and that comes with your camera. And I'm also just going to take this time and install this little VBAT pin, because I forgot to do that earlier. You don't need this, but it's just kind of nice to, it's just super easy, so we're just going to install this too. What this does is it just connects from right here, and this is just VBAT. So the battery's voltage is connected to these pins. That you could plug another ESC here basically. It's just battery voltage, and we'll plug that into the plug here, not the buzzer. This is the plug that you use if you want to power a buzzer. And then this one right here says VBAT. So we're going to plug it into this one, making very sure to observe the polarity. So this is just a little voltmeter. It'll sense the voltage of the battery, and then it'll tell the flight controller. So you could have this send telemetry back to your radio if you do that, or you could use this to automatically enter a failsafe mode, or you could use this to have it make different beeping tones with the buzzer if you use that. So I'm just going to install it, but you don't need to. If you just time your flights, it'll be all right. So to the left, I've selected battery voltage, and to the right, I've selected 5 volts. So this is going to take the 5 volt regulated and give it to the camera, and it's just going to give the video transmitter the battery. This way I can use 3S and not only 4S. Anyways, so now we need to solder. I mean, it doesn't matter exactly which order, but I just need to connect a power line from the 5 volts and use that to power the flight controller, and the flight controller will also power your receiver. So you just need some sort of a little servo plug like this, or maybe just steal one of these from one of these plugs that come with the flight controller. This is from a servo extension wire, or you could get it from an old servo or an old speed controller, or pretty much anything that you just don't mind chopping it off of. So I'm going to take out the white pin because I don't need that. Yeah, you just pry that back. So if you just lift that tab there, this should be able to just slide right out. And I'll just use this plug now. So before I actually plug that into the flight controller, I like to just double check with a multimeter to make sure that everything's outputting what it's supposed to be. Five volts and battery voltage. Power plug right here. You can choose any of these rails, any of these plugs. I'll just go right there. That should do that. All right, so now the flight controller should turn on when I plug in the battery. And the flight, so it went do it, so that means it's armed, the lights turned on. And they armed because they're having a signal from the flight controller, so the flight controller is on. Awesome. Okay, so receiver time. You need some way for your transmitter to be able to talk to the flight controller. So you could use a PWM type receiver with all these individual plugs, and then plug these into either side of the flight controller, both IO1 and IO2, or you could do a direct solder with SBus right there, or CPPM, or use pretty much any of these ports, just not that one, because that's actually the USB port. That's UART1. Now what we're going to do is I'm going to use this X4R with SBus, XR4SB for the Tyrannus, and that's super easy because it's only one plug, just one SBus plug. And then you can basically chop the rest of these off or depin them and plug this into IO2, just right here. Now these aren't very strong, so it's a good idea to put some super glue or something around the outside just to make sure that doesn't pop off. Okay, so once the receiver is bound and connected, let's go into CleanFlight and configure this.
In order to connect your receiver to your flight controller, first have your transmitter and your receiver bound together, and then you're going to need to plug the quadcopter in so that the receiver has power, because the USB won't supply the receiver with power. And as with any time that you have the battery plugged in and you're working on CleanFlight, do not have the props on, no props. So you set the receiver up here in the configuration tab in the receiver mode. If you're using a PWM receiver, use parallel. This button, if you're using PPM, you use this one. If you're using serial, then use this one. But in order to enable serial, first you have to go into ports and you have to enable UART3 here for serial. So you turn on the serial RX on UART3 if you're using a UART3, which you probably are. Then once that's enabled, save and reboot, you go to configuration and you enable serial, and I'm using SBus, so I'm going to click SBus, but if you have a different serial type of connection, then you can choose that there. And once that's set up, you go into the receiver tab. Assuming your transmitter and your receiver are bound and you have the COM port set, configure the receiver set up correctly in configuration, you can go into receiver and you can verify that everything's working correctly. Now, you want to make sure that the right stick roll back and forth works, pitch and throttle all make sense. If not, then maybe you have the channel map wrong. So I have channel 1 as throttle, channel 2 is aileron, because that's the way that my Tyrannus works. But if you had a different type, then you could set it. So we can see that my channels are at 1500, so that's good. Right there in the middle. If it's not landing quite at 1500, then you might have to do a little bit of tinkering and searching on the web. So you can see that all these channels work, and by default, yaw or throttle stick down and yaw to the right will arm the quad, but I do not have that set up. So that's what default is, and then you can also set some auxiliary switches, and we can tell those what to do in the modes tab. So in modes, I have my arm switch as aux2, so when it goes in the green, then it arms the quad. And then I have air mode basically all the time. And I only use air mode, but there's angle mode, which is where if you enable angle mode and put that on a switch, then angle mode will limit your maximum angles of bank. Basically, you can't roll over, and full stick to the left means it'll go to a certain angle and stop, and it won't let you go any farther, and it's self-leveling. Horizon is like no angle limits, so you're able to roll and do things, but it's going to always be trying to pull you back towards level. So I find that annoying. You might find that stability nice. Other things, you could turn on the beeper, so you can assign the beeper to a switch, or black box is a data logging thing that you can do. And that's how flight modes work. You choose the channel, you choose the range, and then you can move the range. Let's see. Yeah, so every time I put this switch auxiliary 1 into this range, then it turns that on. Anyways, now your receiver set up. You could use these wall mounts for Foxier style cameras if you want, or this plate for board cameras, or maybe the lens mount, or I'm just going to use the floor mount. I'm going to mount my video transmitter to the top plate like this, and I'll list where I got all these other parts too in the description. Make sure that your wires are secure and won't come out into the prop arc, because that is a very close fit right there. Alright, so maybe put a zip tie around your extra wires just to kind of keep them in the middle there. Anyways, this thing looks awesome. All put together. Let's use a zip tie to hold each of the receiver antennas. Receiver antennas go up along the zip tie and are heat shrunk on there. Battery lead just goes and kind of slides into that slot or whatever. Plug into the battery that will sit on top. Put my battery strap through one of these. Alright. Now let's remember to make sure, because the front of the board is that way, so you want to make sure to put in clean flight that we've rotated the board 90 degrees. So I'll show you how to do that. So in clean flight, you just go to configuration, and then board and sensor alignment. You just put the gyro alignment to clockwise 0 degrees. I don't know why, but that's what works. And then also the acceleron. We do have all these sensors. Let's just do that to all of them. Just take all the sensors and say clockwise 0 degrees, save and reboot. And then we can go to the setup page, and now we can see that little quadcopter there. So the quad right here is just sitting on the coffee table flat. So I'm going to hit calibrate accelerometer. Let's grab the quad and make sure that it does the same thing. So since this isn't pointing in the same direction, let's go ahead and hit the reset z-axis. That'll make the quadcopter face away from us on the screen, just like this one in my lap. So let's go left, right, up, down, yaw left, yaw right. Okay, yeah, that matches. So now the quadcopter knows which way is forwards, and it will actually be able to work. Awesome. So unfortunately, I found one of my speed controllers was suddenly unable to start the motor. Remember that the kit in my description comes with awesome ESCs, but for me, I tried fixing them by updating the firmware.
No, that's not okay. So there's this really cool application that only works on PCs called BLHeli Suite, and you can use it to program your ESCs. It works by BLHeli pass-through, which is where you actually use your flight controller as an interface to talk to and to program your speed controllers with this program. And your flight controller has the newest version of CleanFlight installed on it, and then you just have the speed controllers connected to it. And you connect that via USB. You go to the COM ports and you connect to it. And you give the speed controllers some power. Plug those in. And then you can go over here and hit check. And it's found for speed controllers. And it's found that they're running Afro 12 amp firmware 14.6. And that's because I updated already. So with this program, you can change the motor direction. So you can, this is where you'd go and you'd select, say, motor number 3. But this is where you can change the motor direction. You just go, now I want it normal. Or I want it bidirectional. That would be for an RC car, or if you wanted to do 3D flight with reverse thrust. I'd like to try that next. So it's on reversed, and then you just hit write setup, and then it'll write all the changes that you made. And there, and you can select each speed controller individually, or you can select them all, where number 1 is the master, and then it'll copy everything over. Anyways, to update the firmware, you do flash BLHeli. It'll go over here, it'll say target ESC is number 1. It's already selected Afro 12 amp because that's what it sensed before. For multi-copters, you could change that if you want for like helicopter stuff. And then the latest version, which is 14.6. Now what was on this before was 13.2 that was on these speed controllers. That's just pretty far out of date, so I just updated it to the latest version. You say newest version, you say okay, you say yes, I would like to flash this. Then it flashes that speed controller. And you just do this to every single one of them, all 4 of them, and that will update the firmware. Alright, so here it is all put together. Just a little bit of tidying up and securing some wires, just making sure that none of the wires are going to come out and get hit by the propeller, because the prop arc is really close to everything, and even to itself, right? So nothing can come out. Now, updating the firmware seemed like it fixed my speed controllers, but it still wouldn't start, that one speed controller. So I must have got a dud. So what I actually did is I actually replaced all of the speed controllers with some Emax Lightning 30 amp ESCs. And so I'm going to fly this with a 1300 milliamp hour 4-cell, which is awesome. It's the racing kind of pack. But if you wanted, you could do 3-cell or a bigger battery or something. But this is what I want for maximum performance. I'm going to be flying one of these. This is a 75C 4-cell. All right. Another thing this kit doesn't come with that you're going to need is a battery strap of some sort. I got long ones to go all the way around, or short ones to go around the top plate. Unfortunately, it didn't come with any, so you're just going to have to order yourself some too. All right, let's fly this thing for the first time. Sorry, we're just gonna... Just do a slow